There are many rules that we need to know in order to calculate a derivative. The first and most common is called the power rule. It says if y equals a times x raised to the b, then the derivative of y with respect to x is b times a times x raised to the b minus 1. So you take the exponent on the variable x, which in this case is b, and you multiply it by the coefficient, which is a, and then you drop the exponent on the variable by 1. For example, if we're given this function, y equals 4x cubed, the power rule tells us the derivative is 4 times the exponent 3, so 4 times 3 is 12, times x raised to the exponent minus 1. So in this case, 3 minus 1, or 2. So we get 12x squared for the derivative. Three common special cases of the power rule are y equals a, then the derivative is 0. If y equals a plus bx, then the derivative is b, just the coefficient on the variable. And if y equals a over x raised to the b, then the derivative is negative ba over x raised to the b plus 1. The following example displays these rules. Suppose we're given this function y equals 3 plus 2 over x raised to the 0.5. Well, we could use that third rule that we just saw, but the easiest way to do these kinds, where the variable is in the denominator, is to rewrite it with the variable in the numerator and change the sign on the exponent. So we can rewrite x to the 0.5 in the denominator as x to the negative 0.5 in the numerator. And so we can rewrite this whole function as 3 plus 2x raised to the negative 0.5. Now we can use the power rule to take the derivative of it. We multiply the negative 0.5 times the 2, and we drop the exponent by 1. So the exponent is negative 0.5 minus 1 is negative 1.5. Notice the 3 drops out because from our last rule page, the derivative of a constant is just 0. And so the derivative of 3 is 0 and it drops out. And so we get negative x raised to the negative 1.5. And usually we like to represent things with positive exponents. So we would want to rewrite this as negative 1 over x raised to the 1.5. Again, if you want to change the exponent from negative to positive, you just have to move the variable from the numerator to the denominator, or vice versa. The sum rule is if y is equal to f of x plus g of x, so it's just a function of x plus a function of x, but they're two separate functions, f and g, then the derivative is just the derivative of f of x plus the derivative of g of x. So the derivative carries over addition. You just take the derivative of each term that's being added. This means that the rate of change in y is the rate of change in f of x plus the rate of change in g of x. Here's an example of the sum rule. If y equals 3x plus 4x squared, the sum rule tells us the derivative is the derivative of 3x, which is 3, plus the derivative of 4x squared, which is 8x, using the power rule. The product rule says if y is a product of two functions, that is, if y equals f of x times g of x, then the derivative of y with respect to x is the derivative of f of x times g of x plus the derivative of g of x times f of x. So this says that in order to find the rate of change in y, because remember the derivative is about rate of change, that's what the derivative is concerned with, we have to multiply the derivative of each function by the other, since they are being multiplied by each other in the original function. So let's look at an example of the product rule. If y equals 9 minus x squared times 2x, well, here we see that y is a product of two functions, 9 minus x squared and 2x, so we can use the product rule. The derivative, again, is the derivative of the first times the second, the derivative of fx times g of x, plus the derivative of the second times the first, the derivative of g of x times f of x. So first we want to look at the derivative of f of x, which we call 9 minus x squared. Well, the 9 drops out, and using the power rule, the derivative of negative x squared is minus 2x. So that's where we get that first minus 2x from. And we multiply that by g of x, the second function, which in this case is 2x. And so that's where we get the first part. The second part is the derivative of the g of x which is the derivative of 2x, which is just 2, and we see the 2 on the end there, and we multiply that by f of x, the original f of x, which is 9 minus x squared. And then all we have to do is simplify, and once we simplify that out, we get minus 6x squared plus 18. A special case of the product rule is sometimes called the quotient rule. It says if y is equal to f of x divided by g of x, then the derivative is the derivative of f of x times g of x minus f of x times the derivative of g of x over g of x squared. And this seems like a new rule, but it's really just a special application of the product rule. For example, if y equals 2x squared over 2x minus 1, the quotient rule says we want the derivative of the numerator, 2x squared, which in this case is 4x, times the denominator, which is 2x minus 1, minus the numerator, 2x squared, times the derivative of the denominator, which is the derivative of 2x minus 1, which is just 2, and then we put that all over the denominator squared, which is 2x minus 1 squared. Sometimes we will need to differentiate exponential and logarithmic functions. We will have to use these rules. If y equals a times the natural log of x, the derivative of y is a over x. And this rule says if y is equal to a times e raised to the bx, the derivative of y is b times a times e raised to the bx. So that b, the coefficient in the exponent of the e, gets multiplied by the original coefficient, a. For example, if y equals 2 times the natural log of x, and this is using rule 8, the derivative is the coefficient 2 over the variable on the inside of the natural logarithm, x, so it's just 2 over x. And using the ninth rule, if y equals 3 times e raised to the 2x, the derivative, now remember rule 9 says we take the coefficient on the x in the exponent, so in this case it's 2x in the exponent, so we take the 2 and we multiply it by the coefficient on the exponent itself, which is the 3 in this case. So we take the 2, multiply it by the 3, and we obtain 6. Multiply that by e raised to the 2x. The original 2x does not change. What if a variable z is a function of y, but y is a function itself of another variable x? In this case, we need the chain rule. So let's say that if z equals g of y, so z is a function of y, we're just going to call that function g. And y is a function of x, we're just going to call that function f. Then the chain rule says that the derivative of z with respect to x is the derivative of g with respect to f of x times the derivative of f of x. So you can think of it as you're going 2 levels down. Z is a function of y, but y is a function of another variable x. So when you want to take the derivative of z with respect to x, you have to kind of do 2 derivatives, and we'll see how this works in the example. But basically, the derivative of z is the derivative of y taken normally, but then multiplied by the derivative of x, since x also influences y and x varies. You have to take into account the variation of x. That's what the chain rule is all about. For example, if z equals 4 minus 0.5x all squared, well, here we can see, imagine that 4 minus 0.5x is y. Well, then z would equal y squared, and we would know how to take the derivative of that. But here we're saying that y depends on x, so you can see that y is 4 minus 0.5x. So we're going to have to use the chain rule here. So the chain rule says, first you take the derivative of the outside with respect to the big function itself. And so we see the exponent on the whole function, and we have to use the power rule. The power rule says you take the exponent, 2, multiply it in front, so we see the 2 in front, multiply it by the original function on the inside, 4 minus 0.5x, and then drop the exponent by 1. So we see the exponent goes to 1 from 2. So that's where the 2 times the 4 minus 0.5x comes from. But then the chain rule says, since the inside of the parentheses is itself a function, we have to multiply the whole thing by the derivative of that. So what's the derivative of 4 minus 0.5x? Well, the 4 drops out, and then the x drops out, so it's just the minus 0.5. It's just the coefficient on the variable x. So we have to multiply that by the end in order to get everything that's going on with respect to z. And that's the end of this review on derivative rules.